Hi, welcome all. We are just waiting for 2 more minutes for other participants to join. Hi all. Hi all. I'm Ashutosh from EdFirst. Welcome to all of you. Welcome Anurag. Let me introduce to you our today's expert edTalk speaker Anurag Yadav. Anurag is a core techie at heart and a Google certified cloud architect, bringing over 2 decades of rich experience in architecting and engineering large-scale distributed systems and software products. While working with global tech giants like IBM, HCL, Blue Yonder, he has delivered many successful products and projects to multiple Fortune 500 clients. This includes development of SaaS systems handling multi-million transactions per day. He has deep expertise in architecting and operating large-scale systems on cloud using containers and Kubernetes. He has long and rich experience in architecting and developing microservices using rational and non-rational database. Additionally, he has always been passionate about teaching and learning. In his journey, he has trained and mentored more than thousands of professionals. Also, he is the author of Software Architecting and Technology of Large-Scale Systems and the bestseller course on Udemy with 20,000 plus learners and a 4.5-star rating. He did his BTech from IIT Varanasi. Hi Anurag, congratulations on becoming a AWS certified trainer. Also.
Thank you, Ashutosh. Hey, Ashutosh, am I audible to you?
Yes, Anurag, you're audible.
Okay.
You can start.
Great. We'll get started now?
Yes, please.
Okay, thank you. Let me first share my screen. If you can see that, then let me know.
Yes, I can see that. You can just maximize it, please.
It's not maximized?
No, it is now.
It is, okay.
Just the bottom bar is visible, the Apple bottom bar.
Okay, I think that will disappear. Should be okay.
It's absolutely fine.
Okay, perfect. And let me switch on my video. If you can see me on video, then let me know.
Yes, we can.
Okay, wonderful. So let's get started. Ashutosh has already introduced me, so I'm not going to waste any time on my introduction. Let's get started with the topic that we have, in which we want to talk about Docker and Kubernetes, and we're looking for specifically things like agility, scalability, and reliability from an application developer or an application architect perspective, that if we introduce them to Docker and Kubernetes, then what is it that they would need to know first? So we'll go into the basics, and then we will, in the end, try to deploy a full-fledged application. It will be a mini system, and I'll show you that in a bit. So obviously, we cannot cover everything in this small session, but anything that is important and it is at the core of these two technologies, we would like to cover that. With that, let's get started. Okay, so we discussed this, that we are going to talk about Docker and Kubernetes, because we are going to do a demo of Kubernetes on cloud. So a little bit, we are going to talk about that too. First, let's start with how do we do development and deployment with Docker containers. So what kind of change Docker containers bring to development and deployment? Just a second. Yeah. Okay. Now, in development, very often what we do is, in order to test our system or to work on our system, we have to install a lot of dependent software. What do I mean by that? So let's say I am a Java developer and I am developing a Java web app, right? So if I have to run this web app, I'll have to run it on a web container, and I will need some JDK or Java runtime to run this container. And obviously, it will be running on some machine which has an operating system. Apart from these things, I'll have to configure the environment variables and any other configuration that is needed to run this web application. Now, if I have to run this particular software somewhere else on some other machine because I am testing it or someone else is testing it, then we will need a machine which should have an operating system, obviously. And this will also require similar or the same software, I would say same software, to run the web application. So whatever we have done on this particular machine, same thing will be repeated on our new machine as well. So let's say on this machine, we have built something, a web application. Let's say it's in the form of a jar file. We will bring that over here and we will launch this application after configuring environment variables and configuration. Here, environment variable and configuration may or may not change. The point over here is that we may have to do it multiple times. And every time we have to test this application or work on this application, we may have to do this again and again. So first problem with this approach is that it is manual, it is error prone, it is time consuming, and it is repetitive. Just to give you an idea how repetitive it is, let's take a large scale system which has multiple components of UI, services, and data. There can be more, but this is just one representative system over here. So we bring in this kind of system which has to operate on large scale. We will have to do this particular process that we just saw in the previous slide for many more components. So we'll have to recreate application environment, right, for many more components. We will have to deal with many environments. So maybe let's say functional test environment, performance test environment, system test environment, and for that matter, even if we have to create production environment, we'll have to do the similar exercise. If we have our production environment or on multi-site, right, Reasons can be many. One of the reasons can be as simple as that we are running a disaster recovery site. Then we'll have to again recreate these applications. The other problem would be that if we are running a large scale system, we may not have just one instance of our application components. We may like to run, depending upon our scale, 100 or 1,000, whatever is the number, we may have to operate at that scale. So if our web application, instead of one instance, if we have to install and deploy 1,000 instances, that's going to be a huge exercise. So that's not possible with traditional means. So we need some automation. Let's start from the scratch itself, that we had a web application. And if we want to automate the process of deployment of this web application, then what are we going to do? Possibly, we will create some script, right? Automation script, where this script can take care of installing the software. So this software, let's say this JVM, in this case of this web application, this web container, let's say it's Jetty, right? We can write a script to install all this, and this will make this process automated and will not be making mistakes while doing this process. Other thing is that it will have specific versions, right? So now if somebody is going to use this script, then the version will be taken care of. If we have to launch some software, we can probably at the end of the script, we can even launch that software. In this case, we are trying to launch this web application after installing the required software. So this way we can develop scripts and we can provide some automation. Hope we are fine up to this point. If there is any question, let me know. Otherwise, I'll move forward. So basic stuff so far. Let's just move forward. Now, this is a reliable process. It is easily repeatable also. We have to just execute the script. What's the problem? Problem is that installation, if we have to do with the script, each time I launch a new environment, this application, if I have to do installation through this script, this can take time. Imagine if I have to do it in production or in some automation, in some test or automation, then this installation is going to take time. It can take probably 5 minutes to 15 minutes, depending upon what software we are installing, right? So we may have to download this software and then install it. It can take time. So this process may not be good enough. We probably can do better than this. What can we do? The next improvement that we can bring in is virtual machine. And it's not a new thing. This thing has been there for very long. I'm just taking you through the sequential steps so that you meaningfully understand why we want to use Docker containers, right? So we will bring in virtual machines, and for bringing in virtual machines, let's say continuing on our web application example, here what we have done is on our operating system, we have installed special software called Hypervisor. There are different types. There are 2 types of hypervisor, but I'm going to talk about hypervisor of type 2. Doesn't matter. It's a hypervisor. And on this hypervisor, what we can do is we can run other operating systems. So let's say this machine is a Windows machine. And if I install this hypervisor software on this machine, now on this Windows machine, I can run Linux software, Linux operating system. So that is what hypervisor will provide me. With that ability, what we can do is we can choose any operating system that is needed. On that operating system, once we launch a virtual machine through this hypervisor, we can install the required software, right? So in this case, it's JDK, let's say, and let's say a web container called Jetty. we will also push in our jar files and we will configure the environment, and our entire environment will be ready, right? Once our entire environment is ready, our application we are able to run our application on this machine. This whole installation process would have modified the disk of this machine, meaning everything is now on the disk. So if we now take an image of this particular machine, the disk image, we mirror it, we will get the entire application as we installed on this and configured on this machine. So whatever has gone on the disk of this machine, we can take an image of that. Once we have taken the image, what we can do is we can go to a new machine where we have this hypervisor, and there we can spawn a virtual machine. That virtual machine, here the OS will boot, and it will have all the software that we had already installed on this image that will be available. And if we have configured some services to run on the OS start, then those services will also be launched. So if this web application is a service, that web application will also start after the machine boot. If you have seen a virtual machine, it is almost like you are running a machine. It boots up first and it runs any software that it needs to run as part of the auto start process, right? So that's your virtual machine. Now with this virtual machine, we have got the ability to replicate our environment much faster. All we need to do is create an environment, then create an image, and then on any other machine where we want to recreate this application, what we can do is we can, sorry about that. Okay. We can launch this environment as a virtual machine. So this process is pretty reliable. It's automated, right? It's not manual in the sense that we are not manually installing the software every time. Whatever version of software we will choose over here, the same version we will get over here. And it is much more time efficient as compared to the script-based automation. With this approach, what we can do is we can, on a same machine, we can even start multiple virtual machines. So let's say if I have multiple components in my system, UI and one service, and let's say one database, I can do that on this virtual machine. This virtual machine will allow me to partition the resources. So let's say there are 12 CPUs on this machine. I can allocate 4 CPUs for this, 2 CPUs for this, and 6 CPUs for these 3 separate virtual machines. Similar thing we can do with memory as well, right? So virtual machines, they'll provide us isolated environments where they can run independently without interfering each other, right? So that's about virtual machines, and we saw some of the benefits. Now, what are the problems? Why are we looking for containers? Now, the problem here is, if we go back, this image that we have, it includes the entire OS, right? So the image size that we get is pretty huge, depending upon what you have installed on this machine, what's the operating system size, right? You can get pretty large image sizes. And if you have to move them around because you have to launch them on different environments, this can be a constraint. The other problem with this is every time we launch a virtual machine, first the OS has to start. And this OS, if I haven't mentioned it yet, we call it guest OS because it is running on a host operating system, which is running on the physical hardware of this machine, right? So that's why we call it as guest OS. And this actual operating system will be called as host operating system. Now this guest OS takes time as if it is starting from scratch, right? So this process is time consuming, not as time consuming as the script automation, but it is still time consuming, and when we can do better than this. Let's see what we can do. With virtual machines, instead of virtual machines, we can use something that is called as containers. Now, if we have to launch containers, we will need something that is called as a container runtime. So in this presentation, we will focus on one such container system, which is called as Docker. This is the Docker logo. Here, instead of having a hypervisor, we will install Docker runtime on this machine. The speciality of this container runtime is that if we launch containers, containers are very much like virtual machines. So whatever we have discussed about virtual machines so far, right? It is true for containers as well, right? There is one critical difference, and that is the difference because of which we are interested in containers. Let me just check if there are any questions at this point. There are no questions, so I'm going to move along. If there are any questions, you can post them on webinar chat. In between, I'll take a look at them and I'll try to answer them. Okay, someone is asking about Docker daemon. So when you launch a container when you install a container runtime on any machine, after that you launch a process. In case of Docker, you launch Docker process, which is called as Docker daemon. Any command that we send to Docker goes to Docker daemon, and I'll come to that instead of talking about that over here. Please wait when we talk about Docker daemon later. The thing that we want to understand over here is that, like virtual machines, we can install containers over here. The difference is that containers are pretty lightweight. If you see virtual machines, they have guest operating system in them. But if you see a container, there are no operating systems over here. What we have is operating system libraries, right? And if any system call needs to be made from, let's say, our application, that will, through this Docker runtime, this will actually go to the host operating system. So we do not provide any implementations for these system calls over here. What I'm trying to say over here is that in case of virtual machines, you have an operating system, a guest operating system running over here. In case of containers, there is no guest operating system running over here. We have a container. If there is any call to an operating system, container through its operating system library interface, it will send those calls to the host operating system. This host operating system is actually going to implement those system calls. Let me just take a look at, there is some question. How can we differentiate between hypervisor and Docker runtime? I think what you're trying to ask is, what is the difference between hypervisor and a Docker runtime? So hypervisor is a software which is used for launching virtual machines, and Docker runtime is a software which is used for launching containers. Containers, you can think of them as lightweight virtual machines which do not have operating system in them, right? Then does that answer the question? How can we differentiate? And you install them. So if that is the question, how do you know them? Which one is hypervisor and which one is Docker runtime? We actually install them, so we know that in case if that was the question. The other question was, is it possible to explain how it will work in .NET Core? So .NET Core, just see .NET Core as an application, right? For that, on, let's say in case of a virtual machine, you will have to install some software. And in case of .NET, it won't be JVM. You will be installing .NET, right? And whatever container, let's say IIS, I'm not very familiar with .NET, but then let's say any container runtime that is needed in .NET, you will install that. There is, let's say if you are running on IIS, so you'll have to install IIS. On top of that, you'll have to provide your web application as well, which you would have written on for .NET. So the important point over here is that don't look at it in terms of .NET, Java, or Python that you are working on. Look at it from the perspective of an application. You are developing an application. That application has some software dependencies. It can be JVM dependency in case of Java. In case of .NET, it can be .NET dependency. You'll have to install all those dependencies and you'll have to package them into a virtual machine. In case of virtual machine, you also have guest operating system. In case of containers, we just have container. Container is like a virtual machine, but you do not have a guest operating system running in there. I hope that answers the question. Some of these questions will get answered once we get into the Docker containers. We have limited time, and I understand that there will be multiple questions. I'll try to answer as many as possible, but some of them will definitely get answered once we look at the demonstration. In any case, let me just read one or two more questions. What specific applications are preferred to run into virtual machines only, and machine are a good choice against container? In general, anything that you can run on an operating system, you can run it in a virtual machine, and so in a container. The other question, let me just check. The question is, do we need the same OS to entertain the system call from the Docker's given system library from the Docker and the operating system? So if I need to run Linux containers which are based on Linux, there can be different flavors of Linux, Ubuntu, Debian, and other flavors. I'll have to install Docker Runtime that will work on Linux. If I am working on Windows, I'll have to install a different Docker Runtime, which will understand Windows commands. And once you see this in the demo, I'm going to talk about that again, okay? Hopefully that will answer the question. Does Docker divide the host resource between containers like VM? Resources means memory or CPU. Okay, that's the last question I will take on this till we get into the demo. So in case of virtual machines, we can strictly partition the resources, right? We can say that 6 CPUs belong to this, 4 to this, and maybe 6 to this. Like this, we can do a division. In case of containers, what we can say is we can specify the limits. What is the maximum CPU this container can use? What is the maximum this can use? And what is the maximum the other one can use? Similarly, we can specify not just CPU, but memory as well, right? So we can do that. If we do not specify that, then they can even share the resources provided by the operating system. So let's say in this case, they can share CPU and they can occupy any memory space as well. And that's helpful also sometimes because let's say one particular service is not getting too many calls and there are enough CPU cycles available, they're sitting idle, then the other applications can make use of that, right? So there is sharing also possible. But if you want to enforce that, nope, my web application should not consume more than 2 CPUs and my service should not consume more than 4 CPUs, then you have that ability also to specify that. Okay, so I'm going to come back to these questions. I'm going to go into the demo after this. But before we get into the demo, let's just look into what containers are, right? So for a container, like I said, we'll have to, on any machine, we'll have to install a Docker runtime. The next thing that we will do is, here we are talking about Docker containers. So we will create a configuration file which will list what operating system I want, what software I want to install, and we will see this during the demo. So bear with me for that. So the point I'm trying to make over here is we will create a config file, right, which will have all the dependencies, probably the environment that we want to create, and what software we want to run. So we will create one such configuration file, and using with the help of the Docker runtime that we have installed, we can actually create a container image. This is very much like virtual machine image. It just doesn't have the operating system in it. So it's a pretty lightweight in that sense. Now what we can do is, very much like a virtual machine, we can use this image to start a machine, which we will call it as container, right? So this is a Docker container that we will start, right? And this is what the improvement that we have done over here as compared to virtual machine is that we have really made this image lightweight, right? And now we are talking about image that is of size probably in MBs, right? And let's say 200 MB or 500 MB to just give you an idea. This image size obviously can vary depending upon what we are installing. The other thing is that, as you will see this here, because there is no operating system involved, this particular container, unlike a virtual machine, will start really fast, right? Because host operating system is already up. All this container needs to do is it needs to bring up this particular web application. So let's go into the demonstration, right? This will make what Docker containers are much more clear, and hopefully some of the questions that are there, they will get answered, right? If not, I'll come back to them, and whatever it is possible to answer in this time frame, I will try to answer that. Okay, so there are about 350 participants in this particular presentation. I'll try to move as fast as possible so that we can finish it in stipulated time, and whatever questions I can answer, I'll answer them. Okay, so hopefully this is making some sense. What we are trying to do over here is when we are recreating any environment, we want to minimize the time as much as possible. And that is all we are trying to do over here. When we go into Kubernetes, it will all come together. You will know why this is important. Okay, so let's take a sample application. So let's call this application a product service, a service which is responsible for, let's say, listing products or providing us or adding products and all those kind of operations. So let's say it's an e-commerce service, and with this we can view what all are the products that are available for sale. And this is a part of a microservices system. So there will be other services also. And typically in microservices systems, you will also have a discovery service. So I have brought in a discovery service also over here. Now, in order to explain you what Docker containers are, right, I could have started a Hello World application, but Hello World application will not give you a good idea of why we are really using Docker containers. It will give you some idea, but we ultimately want to go to Kubernetes, right? So I have intentionally made this system a little more complex. What I've done is, instead of just one application, right, I have introduced one more application. So in this system, we have two components. Now, these two components should be able to talk to each other, like in any distributed system. Other thing is that we should be able to test our service through some client. And in this case, because this is going to be a REST application that I'm going to show you, I should be able to test it using an HTTP client. Okay, because we are talking about client-server communication and service-to-service communication, we will need some network also. We can use the network which is available on our own machine, right? On this machine where I'm going to do this demo, I can use this network. Alternatively, a better way to do this in Docker is that in Docker, you can create your own networks. And you will see this, I'll create this. By doing this, what we can do is we can isolate the entire system that we are running. We can choose the IP addresses for our machines, right? This network can even provide us DNS, so we can choose the name for our services. So things like certain interesting things we can do through Docker network. So generally, when you are running Docker containers on your machine, right, you will create a network on your machine, right? And this is important when we go to Kubernetes. I will tell you that this network is going to be a limitation. So that's why I have brought in these few things additionally instead of just a hello world program. Okay. So with that as the setup, in case if there is any question on this setup, I'll take that question. And if there are any questions on Docker containers, I will take them up once I finish the demonstration. Okay. Let me just take a look at the question. Does the Docker runtime need to match the host OS? I think we discussed that. And not really. Vijay Lakshmi, hypervisor creates environment. Okay, someone is answering the question, so that's fine. Does the Docker runtime need to match the host operating system? So similar questions, I think. Let's get into the demonstration. Some of these things will get answered, and then we will come back to this. So hopefully you are clear that we are going to launch two services over here, one product service, one discovery service. We will do it in its own network that I will create on my machine. So this is my machine, let's say. It already has a network. On that, I will create a network, and we will communicate with these services in this particular network. So let me show you that. Okay, so I've just written these commands for two reasons. One is for longer commands, I can copy them, and just to make sure that I have shown you everything that you need to understand this demo. Okay. Obviously, I can't show you everything. There are a lot of things with Docker containers, but the idea over here is that, let's say you are developing a system and it has multiple components. And if you have to deploy this system, then what does it take to deploy this system, right? So we will need Docker and Kubernetes. We need to understand that. And that's my goal over here, that you need to understand. Hopefully you'll be able to understand that what I can do with Docker and what I can do with Kubernetes if I have to deploy this any system. And deployment is a complicated exercise if you are dealing with multiple components and you are operating at scale, and we have already discussed that. So with those as problems, what can we do with Kubernetes and Docker? That is what we are going to see over here. So from that perspective, please try to see this demonstration. Let's get into it now. So here I have a project called microservices, where I have an environment where I can build microservices, and I also have environment to build Docker. So I'm going to go into this Docker directory, and I want to build Docker images for microservices and Cassandra. I'm going to explain you how you can build it. Let's say if you want to build a container for a microservice, how would you do that? All other containers, more or less, you can build in a similar way. So in our example, I am going to show you how microservices we can containerize, right? So I'm going to show you how we can do that. I told you that we need to start with a Docker file, right? I told you that we start with a configuration, right? And that configuration I am showing you over here. In this configuration, first thing that I'm going to do is I'm going to specify which operating system I need. So in this case, I have specified Ubuntu flavor of Linux. I can specify other Linux flavors of my choice also. Now, if you look at some of these commands, these are in Linux. These are Linux commands which work across different Linux variants. It can be Debian Linux, it can be Ubuntu, it can be other flavors of Linux. All of these commands will work on them. But if we have to run these commands, so let's say this command apt-get update, this won't work on Windows, right? So there, this particular configuration file will be created by using Windows commands. So here, I'm going to show you an example, a container that can work on a Linux operating system. And here we have a choice of operating systems that we have. And here I have chosen Ubuntu as my Linux operating system that I want to run on. Okay. Now, the next statement over here is I'm trying to install something on this particular container image that we are going to create. So the commands that you see, let's say this particular command, if we have to run on this particular image, we will specify run over here. So run is a thing. It's an instruction to Docker that if you see anything after run, this has to be executed while creating a container image. And what effectively we are trying to say is we are trying to say Docker that when you're building the image, run this command to install some software. So through this Docker configuration, we try to do two things. One is we try to install all the software, right? And in the end, we will launch some software. Okay. So by run, I am installing some software. Again, here I am installing some software. In this case, I have given the instructions to install JDK. Then next thing that I can do, I have done over here is I'm saying to Docker, when you create an image, copy certain files. So these are the files that I want to copy. Please don't worry about the syntax over here, right? We can learn syntax later. In this webinar, I want to give you an idea of certain capabilities that are there in Docker containers. And typically, how do you create an image in a Docker container? That's what I'm trying to explain you over here. Fine enough. So here is an instruction to copy certain jar files into the image because we will need these jar files when we launch our web application. And we are copying these jar files in this particular destination directory, USR jar directory, which will be created on our container image. Okay. Now, the next thing that we are doing is we are copying another script, Docker entry point.sh into USR bin directory. The reason we are copying this particular script is, and it's a special script, because whatever we want to launch when we start our container, we are going to launch through this particular script. Okay. So I'm going to show you what's there inside the script, but just to summarize what all I've explained to you so far, I have explained to you that you can choose an operating system. then you can install some software on that operating system. You can copy those files that you will need. In our case, we have copied the web application jar files. Other thing that I have done is I have copied a script called docker entry-point.sh. And in the end, I am telling the Docker system that this is my entry point, meaning that you have to launch this particular script when we launch a container. This particular part of the script or the configuration will be used for creating image, right? When we launch a container through the image, this command will be launched to start our web application or whatever software we want to launch. So I'll show you this in a bit. It will become more clear. So I've just shown you what all went into this configuration, right? Let me show you the docker entry-point.sh script. In this script, you can write anything that you want to write to launch any application that you are interested in. What I have done over here is, because we are launching a Java web application, here is the command to launch Java web application, right? This script, we can even pass arguments, right? Parameters. And what am I passing over here? I am passing the name of that particular jar file that I am interested in. So I have copied a bunch of jar files, right? On this image, if you see this, if I go back to the Docker file configuration, there are a lot of jar files that I have copied. So I can launch any of those jar files, and which particular jar file has to be launched, which particular application has to be launched, that is coming through this particular parameter, which is an argument to this script. Okay. Bottom line that you need to remember over here is that this script will be launched to run whatever software you want to run. And for that, whatever preparation you need to do, you will do that in this particular script. The script note will not be used for any installation. This will be used only for launching the software, as we have specified in the Docker file, right? In the end, we had specified this, what script we want to launch our application. With that, let me show you the last thing. In our Docker file, we said that copy, let's say this discovery.jar from current directory dot, and that current directory, I'm getting this file from this jar directory, right? So this is the jar directory I have created. This is specific to this particular application. In this over here, I have put all the jar files that I need. Okay. With that done, the next thing that I need is, let me go back in my PPT. Okay, so this is my machine on which we are working right now. Okay, on my machine, I have already installed Docker Runtime, so we are not going to waste time on that. Okay. The other thing that we have done is we have seen this Docker file, right? We have already created this file. I have shown you this. Now, with the Docker runtime that we have, I'm going to create an image, a Docker image, through which we can launch container. Right now, we are not launching any container. What I'm going to do next is for preparing this image. So how can I do that? So that I can use this command Docker, and any command that I execute over here will go to Docker daemon. Docker is already installed on my machine. Any command from here will go to the Docker daemon. Okay, that will implement all these commands. So I want to build an image. Before I build images, let me just show you what all images are there on my machine. So these are the images on my machine. At the top, you see the images that are recently built. Last I built an image 18 hours ago. It was for a microservice. So this is what we are going to do over here. So let's do this Docker build -t. T is for tag, the name of your image. The name that I'm going to give over here is NTW microservice. And I'm saying the current directory, it's the context directory. So if wherever I have said dot, right, it will correlate to this particular directory. Okay. Now let me run this. But let me actually run this command over here at a different location on a different terminal. This is a terminal which is not very friendly for the commands which shows output. So I have another terminal and I'm going to run this particular command over here, but I'll have to go to the directory where our Docker configuration is. So let me just go there. Okay. This is where I'm going to run this. I actually need to be there in microservice directory because this is where our Docker file and Docker entry point.sh files are there. So here I'm going to run this. Docker build a particular image. So now this command is running. It is going to build the image because certain layers are already built on this machine. It will do only the additional job that is needed. What has it done over here, right? It has, if you see, after installing, making sure that JVM is installed, it has, let's say, copied all these jar files. It has copied this Docker entry point.sh and it has created an image. Let me just see. By doing Docker images, what do we have? We have this image in our repository. The image name is NTW microservice, the image name that I gave, and the version is latest. And if you see this, this was created 33 seconds ago. So this is what I have created just now. Okay. So what we have done over here is we have created this container image. Now, the next thing that we are going to do is we are going to start a container out of this, right? So let's see, how do we do that? Is there anyone who is not on mute? There is some participant who is not on mute. Let me see. Request you to put yourself on mute. Okay. If that problem is solved, let me get back to where we were. Yeah. So now I'm going to start Docker container. So if you want to see what all containers are running on your machine, you can do Docker PS. It will tell you what all containers are running. Right now it shows nothing. So let's run a container. For that, instead of, okay, but like I said, we will also need a network on our machine. So anyway, let me just show you what all Docker networks are there on my machine. I'll use this command Docker network ls. Hopefully you can see this. If somebody is not able to see this, then let me know, please. So there are some networks over here. What I'm going to do is I'm going to create a new network, let's say my net1, right? And the command is Docker network create -net1. So this network got created. If I repeat that command, not Docker network ls, I will see this, that this network got created. Now, this network is of type bridge. This will be there only on this machine. This is not host network. And this network will be restricted on this machine itself, right? The machine on which I am working right now. So that's what roughly we mean by bridge network. Now, time to run our containers in this particular network. So let's first run our discovery service. Hopefully I have copied this. Looks like I have. What am I doing over here? Docker run. This is the command for starting a container. -dt is an argument that run it in detached mode. Do not run it on this console. Run it as a separate process. Then this is a port mapping. I will just come back to this. The name of this container is discovery service. Then the next argument to this command is what network I want to run it on. And the network in this case is -mynet1, which I just created. And this is the name of the image. And if any parameter that I want to send this to this particular image, then that parameters can be specified in the end. And in this case, I am specifying a parameter discovery, which will go to my Docker entry point.sh script, and it will use discovery.jar, right? Because I'm passing on this parameter. So let me just run this. It will create some container. If I list my containers, Docker PS, I see that there is a container which is running. It has got this ID, this image it is using. There's the command that will be launched, that will be used at the time of container launch, and various other things. Now let's launch our next service. Let me just stop this over here. So this is running on this console. I do not want to run it this particular way. Let me kill this. This I launched it with name. I'll just explain you that with the name as product service. So I'll have to first kill this. Right now, what all containers are running on this machine? Docker PS, only discovery service. Now let me first explain you this command and then I'll show you. So Docker run, and I did -it, I will make it -dt. So it will not run on this console. And this port mapping, I will tell you what it is. Then this name of this container will be product service. My next argument is network. So this network will be -net1. And here I am passing an environment variable to this particular container. And this environment variable is basically the location, the host and port location of the discovery service that this product service needs to connect to. The point over here is any environment variable that you need to pass on to your container. Remember, if you are running it in different environment, let's say production environment, test environment, these environment variables will be different. So you can pass these environment when you are starting a container. Last thing, like in previous image, previous command, what is the image name? And the last bit over here is what is the parameter that you want to pass. In this case, we want to run product.jar. So we are using product as the argument. Okay, so this will create another container. We want to see what all containers are running right now. These containers are running. And if I want to see what are the logs, right? What that actually, what is the current state of logs of any of these containers, I can use this command, docker logs. And here I can tell what is the container name. So what this container is actually doing, you can see over here, it has launched a Spring Boot application. It's a Java application. In your .NET environment, you will see probably the console, whatever your .NET application puts on the console, that you will see over here. So with this, our system is completely ready. We have launched the container. In fact, we have launched 2 containers over here. This is the state of our system right now. We have created 1 Docker network. We have created 2 services, and they should be hopefully be able to communicate with each other because they are on the same network. But the client that I'm going to use to test my service, product service, that is not on the same network. So what we are going to do over here is we are going to use a mechanism that is called as port forwarding. What I will do over here is that, let's say this particular script sends a request to localhost, right? And port, let's say 80, right? Then I will have to do port mappings in such a way that any request that comes to port 80, it should be actually mapped to, let's say, some port 8080. So let's say this application I have run on port 8080. So this particular port should get mapped to 8080. So from here, from this client, I will use this localhost 80. But because of this port mapping, when I started the container, this request will actually go to port 8080, which belongs to this container. And this request will actually enter inside this particular network. You will just see what I mean by that. Demonstration will make it clear. 2 things you need to observe over here. One is this -p option I have provided, that any request that I'm sending on this machine, localhost, to port 8080 will actually go to port 8080 of the container, right? So that's what it means. Okay, now time to test this particular application, right? One thing that we can do is this particular discovery service, because it is running on port number 8761. I'm going to connect to this localhost 8761. So there is a discovery service running over there. And you can see this discovery service, it is supposed to register the services. So when product service comes up, it is supposed to register with the discovery service. If you do not know discovery service, that's perfectly fine. All I'm trying to demonstrate over here is that product service itself has registered itself with discovery service, and discovery service knows about this product service. So there is communication going on between these 2 services. Now, what about the communication that I'm going to do from my machine? Remember, I told you that I have this script and I have to call this particular service. So that's what I'm going to do now. Curl is my client that I'm going to use over here, curl utility. Let me give localhost. Localhost is actually my machine, right? It has to go to the Docker network. And how will it go? It will go through this port forwarding that Docker will provide. So here, let me check the health of my service. Let's say this URL would be, I suppose, product health. Let me see. We can get back a response. We are getting a response from our service. It is giving us some information. The host name, which in this case is container name, the service name, and the time. I can again execute this command, right? And it will every time return back. So that means I was able to, or we were able to, let me just go to, we were able to launch 2 containers on my machine, right? In a network, these applications were able to communicate with each other. We saw on the web page, right? Through a browser, we connected to this particular discovery service, and we saw that product service was registered to this. Other thing we did is that we through curl client, right, which is an HTTP client, I was able to communicate with product service. And this worked because there was a port forwarding that was in place. We did a mapping of port 800 on localhost with 8080 on container port. This is container port, and this is port on the local host. So hopefully, if you have understood that containers is a nice way of packaging every dependency in container image, and very quickly we can start container images on any machine, then that was the goal of this demonstration. Now we can repeat this exercise for different components that are there in our system, and we will see when we get into Kubernetes how we can make use of that. One thing I, however, want to point out over here is that make a note of this thing, that we did this within a particular network. So this distributed system was able to communicate with different components within a single network. Now, let's say if I have to run this system on multiple machines, then this kind of networking won't work. I will need something special, and that special would be, let's say, Docker Swarm. So that is the name, Docker Swarm. Right? That is a feature that came after Kubernetes, but we have a much better alternative than Docker Swarm. What we can do is we can use Kubernetes K8s is the short form for Kubernetes, and we will see how Kubernetes can provide us network across multiple machines. So if I have to run this distributed system across multiple machines, we will be able to do that with Kubernetes. If there are any questions, I will take up those questions. Otherwise, we will go into Kubernetes. Okay, let me just go through. If there is any question, I need them. So logging off, thank you. Difference between Docker file and Docker compose.yml. Okay, I will answer that question. So if you remember this, the command that I have used for launching my Docker container, it was a pretty big command, right? If I have to, and if you launch your containers in the real world, you will need to pass a lot of environment variables and a lot of other settings. So a better way to manage this particular part is that we create a configuration which is called as Docker compose configuration. So let's say here there is a discovery service, right? We can, whatever settings, whatever arguments that we can pass to Docker run command, we can pass those arguments over here, and we will not have to write this again and again. We can write it in a configuration file, and over here you see how many environment variables that I have used over here. So like this, in production, the environment can be really complex. In order to manage that, we can write all of that in Docker compose file, so that next time if I have to start a container, I will not have to use these kind of commands. What I can do is I can say Docker compose. I can give the name of Docker compose file where I have done the configuration, and I can say up, let's say I want to start some service, and I can give the name of the service. So let's say product service. We saw the discovery service configuration. We can put discovery service over here. Okay. So like that, you can use Docker compose. Short answer is you can simplify your day-to-day working with Docker commands by using Docker Compose. There is what are about resources to learn the basics of scripting. We'll come to that. Some of the questions in the end. How do we get recording of the session? Let's answer that question in the end. What about Kubernetes and OpenShift? Okay, so these are the questions. We do not have a whole lot of time. Let's get into Kubernetes part now. Hopefully, this is making some sense to you, and we are ready to go into Kubernetes now. So before we go to Kubernetes, we will need Kubernetes cluster, right? I'll tell you what a cluster is, but let's say you have to run containers for a large scale system where there are multiple components. Let's say here we have our web application component, there is a service component, a DB component, and there can be hundreds of such components. If I have to launch these components, I will need physical machines, right? On which I can bring up my Docker containers. We have already seen how we can start containers on a single machine. Now, if we have to work with multiple containers on different machines, I will need these different machines. I will need different IP addresses on these machines. I will need a network, right, through which these machines can communicate with each other, or rather these applications can communicate with each other using this particular network, right? We will need that. So if we have to do this these days, the right way to do this is that we do not create this infrastructure on our own. What we do is we go to cloud and we use cloud infrastructure. What we can do on cloud is we can create, instead of having physical machines, we can have virtual machines on cloud, right? And cloud can also provide us network. So you can go on Google Cloud, Azure, AWS, or whatever cloud is of your choice. There you can create these virtual machines and these network. And on top of that, you can launch these containers. So that solves the infrastructure problem. But if you have to, let's say, start, let's say, 100 applications, let's say you have 10 instances and each 10 application components and each require 10 instances. So you will have to go on, let's say, maybe 100 machines, assuming we are in, running one instance on one machine. We'll have to do this work of running Docker containers on 100 machines. That will be a very tedious task. And we'll have to provision network, right, for these machines so that they can communicate with each other. So some of those tasks, they are pretty tedious tasks. These are infrastructure related tasks, and they can be taken care of by Kubernetes. Not just that, many more. We will just talk about that when we are discussing Kubernetes. So let's get into Kubernetes. We have Docker containers. We know we need infrastructure to run those containers. That infrastructure will be provided by cloud, but we need certain more capabilities on cloud before we can run these containers, right? For a large scale system, for a hello world application or the kind of application that I did on my machine, right? You do not need Kubernetes, but you need Kubernetes for certain other things. And that is what we are going to discuss over here. Life cycle and monitoring. If you need...
Hi, Anurag. So sorry to disturb you.
No problem.
Yeah. Just we are running overtime, so just giving you a heads up.
Okay.
The session is from 4 to 5, right? Yeah. So you take your time, finish it up. Just inform
so
me.
I'll try to finish it as fast as possible.
Sure. We have a lot of questions also. So yeah, that's okay.
Okay, sure. So if we have to start, stop, monitor our containers, right? that is some capability we need. You saw this, I was manually starting and stopping my containers. Kubernetes actually can provide us that capability. We will see that. There are certain other capabilities that we need, which Kubernetes can provide us. And one of them is that we need IP addresses or the names of our applications which are running so that we can communicate with each other. So let's say this service wants to call this database. It can call this database, let's say with a name db_1, right? So somebody needs to make sure that if we are launching a database container, right, that container gets a network name db_1 so that this application, this service, let's say, which is running, it can call this database using this particular name. Kubernetes can provide us that, and Kubernetes can provide us that across multiple machines. So we will get multiple machine network, right? And Kubernetes will take care of that. Other thing that Kubernetes can provide us is horizontal scalability and load balancing. So when you are running your application, this is our web tier. This is, let's say, a service tier. We have, assuming we have just one service application, and this is our database tier. If we, let's say, need multiple instances of our web application, let's say web_1, web_2, and we can even have, let's say, hundreds of instances of this web application, then how do we do that? Kubernetes can launch hundreds of web applications for us by a configuration. If we can provide a configuration to Kubernetes, Kubernetes can do that for us, right? This will provide us horizontal scalability. If we need 10 instances, we can do configuration for 10. If we need 1,000 instances, we can do configuration of 1,000 as well. Kubernetes can, in fact, even figure out, depending upon the load, how many instances, how many containers to launch. So Kubernetes can figure that out too. Kubernetes can also provide you load balancers. Once you have multiple instances, in this case, we have 2 instances, any request comes, Kubernetes will provide you the load balancers to balance the load. It can send the load to any of these web applications. So Kubernetes is something that can take care of that. If, let's say, one of your application component, a container, let's say, crashes for whatever reason, then Kubernetes can detect that this container has crashed or not fulfilling the responses. It can continuously monitor. It can do heartbeat check. And if a container is not responding, it can remove that container and it can replace that container with another container so that it provides fault tolerance to our system and high availability to our system. So that's something that Kubernetes can provide us. Other thing that Kubernetes can provide us is, let's say we want to change the version of our application. So let's say our application is right now running on version 1, and there are 4 container instances that are running. And if we have to change the version, we have to upgrade these instances to run version 2 of our application, then Kubernetes can do a rolling upgrade. What it will do is, it will stop, it will add a new container with a newer version, and it can remove some of the older versions. So it will do it like this. It will keep on adding new versions, and it will keep on taking out the old version. So that's what it will do. The new versions are increasing, old versions are decreasing. As soon as a new version comes up, after that, it kills an old version. So that's called as rolling upgrade, and that's something Kubernetes can do, right? So that way, at the end, you will end up with version 2. Okay, so this is Kubernetes application architecture. Because we are running short of time, what I'll do is I'll do a demo, and while we are doing the demo, I'll explain you this stuff. Okay. In order to run Kubernetes we need certain machines, and those machines are called nodes. And these nodes, they form a cluster. Right? Once we create a cluster in Kubernetes, on that top of that cluster, right, these cluster nodes, we can run containers. Kubernetes takes care of the job of where each container will run, on which particular node or on which particular machine a container will run is taken care of by Kubernetes. Kubernetes, how does it run containers? For containers, it needs container images. Those container images we can put in a registry, right? Kubernetes can automatically pull out these container images from a container registry. And once it pulls out the image, right? Let's say it has to launch a web application. It will pull out this particular image from a registry, and on any of these machines, it can launch the desired number of containers of that particular application. For this, we have to do some configuration, and I'll show you how that configuration is done. In our case, we are going to do this configuration for this system, which has got a database, right? In our case, we have a Cassandra database, and I hope my screen is visible and the meeting is still on. Okay, thank you. Thank you so much. Okay, so I'm trying to rush through over here, but hopefully I'll be able to explain you all key things over here. So we are going into a demonstration. That demonstration, as part of that demonstration, we will launch certain services. So whatever you see over here, these are services, right? And these, I will call them as microservices. Microservices we are launching. So these, we have inventory microservice over here, order microservice, product microservice, authorization microservice. These are all stateless microservices. And if you launch them as a set, as multiple replicas, we call them as deployments on Kubernetes. So this is something that we are going to launch through Kubernetes. Again, this is another microservice called gateway service that I am going to launch. And this is also a deployment. So when you launch a single container, that single container is launched in a pod, right? So let's say this is a service. It is launched inside a pod. Inside a pod, you can have multiple containers, but for now, let's consider that within a pod, we can have containers, and ultimately we want to run containers, right? On our nodes, but on our nodes, containers directly don't run. They run on something that is called as a pod. Each pod has an IP address. Kubernetes creates these pods. If you want to oversimplify it, you can even see pod as your container that we are launching, but that's an oversimplification. But if that makes your life easy early on to understand that, you can see it that way too. Okay, so we are going to launch multiple pods, and these pods, if let's say they belong to inventory service, right? Let's say we are going to launch 5 pods for inventory service. We are going to create a deployment for that. Okay. And these are stateless deployments that we are going to create. In case of stateful applications, databases are stateful applications. We will need something different, and that is called a stateful set. Stateful set ensures that there is a disk attached to each stateful set. So we can basically have different states for each of these databases. They can have, store their own data in their own disk. That is something we do not need on service side. That is only needed on database side. So we need something special over there. Deployments won't do. We will need stateful set over there. Okay. Ultimately, what we are trying to do is we are trying to launch certain containers on Kubernetes, on cloud using Kubernetes. So that is what we are trying to do. So for that, like I told you, first we will need a cluster. Right? Here I have created a cluster, which is already created. What is a cluster? If you have to create a cluster, go create, choose a cluster configuration that you would like, and give a name to your cluster. Let's go ahead with cluster 1. Where do you want this cluster? So you can specify a zone or a region. A zone is a data center. So you can choose any data center over here. So you can want to run in US South, you can run it. You want to run it in, let's say, some other location, Europe location, you can choose that. Once you have done that, you can choose Kubernetes version that you want. I'll just show you the important things. The other important thing over here is how many nodes you want to run. These are the physical machines that will be launched, right, on which we will run our containers. So I'm going to choose 3 over here. Okay. The other thing that you can choose over here is that what Docker runtime or what other container runtime you need. So in this case, let's say you can choose Ubuntu operating system and container, or we can go with default also, that the machines that we are going to launch Kubernetes, it will have this container optimized operating system. On top of that, it will launch, it will use containered runtime. Instead of Docker, you can use containered also. If you want to use Docker, there are options for that also. Let's say container optimized OS is the operating system, and Docker container you can use. I'm going ahead with default over here. Okay. Now, you can choose what kind of machines do you want, right? How many CPUs each machine should have. You can, let's say in my case, machine with 2 CPU and 8 GB memory will be sufficient. I can choose what should be the disk size on each machine. So let's say 20 GB. So these are the configurations I have already chosen. And if I hit create, this will create a cluster. Okay. In this particular case, I have already created this cluster. This cluster has got 3 nodes. It has all these 3 nodes put together. They have 6 CPUs in total. And we have got this 24 GB memory available on each machine. Basically 8 GB on each machine and 24 GB in total. So this is a Kubernetes cluster. Kubernetes has created this for us on Google Cloud. This will need certain Google Cloud capabilities as well. And that's why we are on Google Cloud. Okay. Now, after this, we are going to deploy our application on this. How do you deploy your application on this? First thing that you need is you need a container registry, right? We need container images, right? Those Docker container images. For that, we need some registry where we can host these container images so that Kubernetes can pull these images from those container registry. So what all images we have in this container registry, I have already uploaded. If I go inside this, there are 2 Cassandra and microservice. So these are 2 container images. If I go into microservice, I see that there are different versions of these images. There is a latest version also that we are going to use. I uploaded this 2 days back when I created this registry, and that is what I'm going to use. If you want to use C for Cassandra, for Cassandra database also, there is 1 image over here. Okay. So what we have over here is, if you see this, we have started a cluster which has got 3 nodes. I will just show you that, those 3 machines. And we have registry which has got all the Docker images that we need. Now we are going to create configuration for Kubernetes. Kubernetes will look at this configuration and it will create these containers. For these creating these containers, it will pull out Docker images from this Docker registry that I have just shown you. In case you are interested in what is the size of an image, let's say for this Cassandra image, size is 189 MB, much lesser than a virtual image, virtual machine image that you would create, which will be in GB, right? Okay, so let's go to the configuration now. I have a configuration already on this machine. This is my host machine right now, the machine where I am working right now. And I'll take you to a directory where I have Kubernetes related configuration. It is there in this config directory, right? I have different configuration for different services. First thing that I'm going to do is I am going to connect to this particular cluster. Let me just bear with me for that. If I have to launch any command on this cluster, first I'll have to connect to this cluster, and that is what I am going to do. So let me go to the cluster in Kubernetes engine. Through the menu, you can actually navigate and go to Kubernetes cluster. There is a cluster that we saw earlier on also. We will copy this command and I will execute this command. Now, any command that I execute using kubectl. Kubectl is a utility for issuing commands to Kubernetes cluster. Now, when I issue any command through kubectl, because I have connected to this particular cluster, all commands will go to my cluster. What do I want to execute? Let's say I want to apply a configuration, apply -f. My configuration, let's say, is there in config map. In config map, let me just show you what is there. It has one set of configuration that I need. What I have over here is, in Kubernetes format, what I'm trying to put over here is whatever environment variables that I will need. I'm not getting into the syntax of this configuration due to lack of time. So only thing that you need to keep in mind is in this config map configuration, I have put environment variables that our application is going to need. And I'm showing you right now how to execute a Kubernetes command to a cluster. So here I'm saying Kubernetes apply this particular configuration, which is there in config map file, right? And what do we have over here? We have environment variables over here. So I'm going to execute that. So I have executed that. Now what that does is, if I'll go to, this is Kubernetes engine. If I go to secrets and config map, if I go there, I see that there are some configs that got created. Let's say Cassandra config. Cassandra config has got those environment variables that Cassandra needs to know about. Similarly, for our services, there is another configuration, service config. This is just a name that I have given. It has environment variable for launching our microservices. So let's say what should be our Java heap memory, what is the username and password for Cassandra database, right? It has to connect to that. So all that information is there over here. Now with that, we are ready to launch the apply the configuration for our Cassandra database. So For Cassandra database, configuration is there in cassandra.yaml file. It is a typical configuration that we do. What we do over here is we specify the load balancer service that is going to front Cassandra, and we specify the container configuration. Let me just quickly tell you what it is. And very soon we will launch this. So in this demonstration, in order for these deployments to work with Cassandra, we have multiple instances over here. We will need a service, a kind of load balancer, which Kubernetes calls as a service. So we are going to provide configuration for that, and we are going to provide configuration for Cassandra container. So the top configuration that you see is for the load balancer, which is called as kind as service. Here we are saying that this service will listen at port 9042, right? And then this service is supposed to route requests to container, and those containers will be launched by Cassandra pods. So Cassandra pods is the information. I'm going to skip this. Let me just show you. Let me just summarize this configuration. Here we need to tell what containers are we going to launch, and what do we need to tell over there is that what is the name of my image. So that information I need to provide. Other important configuration is replicas. How many instances we want. So here I have specified 3 instances. I can change this. If I make this 1, it will launch only 1 instance. So let me just launch this. Okay. So it says, actually before launching this, I need persistent volumes. Let me just delete this. Just bear with me for a second. We will redo this. Before this, we need some disk space to be allocated for this. So I'm not explaining that, how to create that, but you know what I'm telling you over here is that we can allocate certain disk space for our those kind of containers which will need to store data persistently. In this case, Cassandra is one such component. So we have created this. Let me just now run that command. Deploy component config cassandra.yaml. Not that command. kubectl minus apply minus f cassandra.yaml. Okay. So I'm applying that. This should create containers for Cassandra on the database. For that, I will go to Kubernetes and Kubernetes engine, and there clusters we have already seen. There is something called as workloads. So I'm going to workloads. If you see this, it has tried launching a container over here. Now it says that image name is invalid. The reason is that image name, there are certain variables that I have not substituted over here. So either I can hard code that right over here, or I can use some script to actually to substitute these variables. So I'm going to use a script for that. Let me first undo what I just did over here. Ignore this step. Okay, let me, the script will take care of substituting those variables. So I'm going to run this. Okay, hopefully this time it will run that command, same command that I tried earlier, but after substituting those variables in my configuration file. So it is going to create these Cassandra pods. If I go there, right, it will create some pods over here. So one by one, so this is one pod, which has got a container. The name is Cassandra pod 0. You will see that it will create 3 containers over there. Okay. In the meantime, let me run this for all my containers. So I have a small automation over here, which will run this kubectl apply -f and configuration file for all rest of the components. So I have not shown you the configuration. It will be similar to what I did for Cassandra. But now, because we do not have time, so I'm going to run that entire configuration. So if you see this, what we are doing over here, again, we have applied config map configuration, Cassandra configuration, gateway service, authorization service, product service, inventory service, order service. So we have done that. We have given instructions to Kubernetes to create all these containers. So if I refresh my workloads, it is creating them one by one, but it will create them only after Cassandra is launched. So these except gateway service, inventory, order, product, and authorization service, which deals with Cassandra, they will start only after Cassandra database is up. How do you specify that dependency? You can go into any of the configuration. Let's say go into inventory service. Here, apart from the other configurations that we have provided, I have provided this init container, which says that monitor only if Cassandra is up, then only you go to starting off this inventory service containers. So we have that capability to do that in Kubernetes, so that the applications are launched in Kubernetes in a meaningful sequence, in the sequence of their dependencies. So they are getting launched over here. If you see this, for Cassandra pods, it has created 2 out of 3. So in total, we need 3. 2 it has already created. If I go into Cassandra pods, right, it will show me that there are 2 which are created. Cassandra pod 1 is running. It will do its health check and it will mark it as completely running after that. So once these Cassandra pods are up, these other service microservices will also start coming up. I'll just refresh this because, okay, they have already started coming up. So these services, they have already come up because there was at least one instance of Cassandra which was available, fully available. Okay, so this way your this part is achieved. We have seen this, these Cassandra pods, they are coming up. And the other thing that is happening over here is that these different microservices, they have come up. In case of Kubernetes, we have this ability to specify how many instances. So for inventory service, order service, there are only one instances that we have brought up so far. If you see this, let's say this inventory service, 1 out of 1 is up. Okay. Very soon I'm going to scale this up and you will see that I can scale this up through configuration. So all these services are up. What about these load balancers? Let's just see. These load balancers are provided as part of services. So those are workloads and these are services. So there are different kinds of services. Cluster IP services are those services which can listen to requests, or these are those load balancers which can listen to only internal requests. Okay. And in case of gateway, I have created a different kind of load balancer, which is an external load balancer. I will show you this configuration. If you see this, this is the configuration for load balancer for a gateway service. Here, the type of this service that we have chosen is load balancer. If I look at any other, let's say, order service, there the type is cluster IP, meaning this load balancer can listen to only internal request. So this way, if we create this kind of configuration, these load balancers are also automatically created. So our load balancers are ready. Our workloads are also ready. And because we can provide health checks in Kubernetes, Kubernetes can determine they are in ready state or not. Now, what I'm going to do is I'm going to make a call to this particular cluster with a client. So I have this test script and I'm going to make a call to this Kubernetes. So for that, we need to make a call to this gateway service. And for that, we will need IP address of this load balancer, which will send request to gateway service. And gateway service, depending upon what is the URL, it will route the request to different services. So if the URL is has products, the request will be routed to product. Okay, so that's the application part. It has nothing to do with Kubernetes. What has to do with Kubernetes over here is we will send a request to a load balancer, and that request will be forwarded to gateway service. And gateway services, like any other service, it will forward request to any other service that it needs to forward this request to. So let's first get the load balancer IP address. How do I get that? Go to services, which are load balancers. So if this is the IP address. So I'll copy the IP address from here. I'll have to provide a complete URL. So let's say curl utility if I use. And if I give this particular, and let's say I want to go to product service. Let's first go to gateway service. I want to check, there's a URL called health in gateway service. So it is giving me response from gateway service. Okay. Now let's say I want to go to product service. So in this, what I will do is I will put products over here. Gateway service will look at this URL and it will route the request to product service. Now I'm getting a response from product service. Okay. So what we have done over here is we are sending requests to this particular load balancer. It is routing requests to gateway service. In first case, gateway service itself handled this. In the next case, in our URL, we had products. So that request was routed to product. Okay. Now these were simple requests. I can send more complex requests, which will actually do this full execution right up to Cassandra database. And for that, I have created a script. I'll give this particular script an argument, right? This particular IP address, just to tell the script where it needs to connect to. And it will launch bunch of curl commands, right? So let me just execute this. If you see this, these curl commands, we are getting an output. All these requests are going to our Kubernetes application that we have created, and we are getting responses. In this case, we have created one order. If I launch this script again, it will create more order. And the inventory, in the end, I am showing inventory over here, 999, 4998. If I launch this script again, it will create more orders and this number will reduce. So if you see this, 998, 4996, this means that a request is, if I launch this again, it will dip even further and more orders have got created. What I'm trying to show over here is that there is some persistence. It is able to every time go into the database, it creates an order and it is able to decrease the inventory. And whenever we fetch it, we see the latest figure. So this is a complete chain that we were able to do with this. the last thing that I will show you over here is, and after that I will take questions. We can scale this up. And how do I scale? I can issue a simple command. I can say I want replicas 3 and for my deployment, right? What all deployment I want, let me just. So these are the deployments that are running. I am going to say that for auth, service pods, increase them. Gateway service pods is nothing but the name of the deployment, right? When we create Kubernetes configuration for a container, we say to which deployment group it belongs to when we want it to be launched as multiple replicas. So for all these replicas, I'm going to scale them up, okay? So it's a simple command, kubectl scale -- replicas to 3 and deployments. I've given the name of those deployments. Let me execute this. It says that it is scaling them up. What does that mean? Let's go to Kubernetes Cluster. Let's go to workloads. We go to the workloads. Now they are not in okay state. These workloads, they are being scaled. It says that for product service, 2 out of 3 are available. Earlier, what we had over here is 1 out of 1 is available. Everywhere it was 1 out of 1, except for Cassandra, where we had 3 out of 3. So here it is scaling up these containers, the number of containers that are running, right? And if I refresh this, we will see that there are more number of containers. So let's say if I go to product service pod, right? There are 3 pods for this product service. One of them is running, another one is still initializing, and the other one is also in an intermediate state. And Kubernetes can figure this out while it is scaling up. If I send any client request, right, this will work absolutely fine, right? Kubernetes will send all these requests to only those containers which are up. So Kubernetes load balancing will make sure that the request goes to only healthy instances that are up. Okay. This will take a few more seconds, I believe. So they are almost there. Let's say product service pods. So there are 2 of them which are absolutely ready. There is third one which is getting ready. While I'm showing you this, let me also show you where they are running. So in Google Cloud, if I go to compute engine is any machine that you create. So if I see what all machines that were created, there are 3 machines over here. These 3 machines, those green ones, these are the machines that Kubernetes cluster created for us, on which our entire Kubernetes application is running, right? All the containers that are being launched, they are being launched on these machines. These are the machines which has got 2 CPUs each and 6 or 8 GB RAM each. So these are those physical machines or virtual machines that Kubernetes has created, not physical machines, virtual machines. Okay, let's go back to our Kubernetes engine. Let's see the workloads, if they are up. See, all these workloads are up. So this way we were able to scale up our system. You can, other thing that you can do is to check high availability. You can, let's say if you want to kill a pod, I will go to a product service pod right? And I will delete this pod. If I refresh this, this says that product service availability is not complete because 3 out of 1 pod has been deleted. What it will do is it will start a new container. If you see this, the number of product containers are right now 4 and total target is 3. 4 they are because there is 1 pod that we deleted, which is ready to get cleaned up. At this point also, if I send any request to my system, right, it will work perfectly fine. These requests, by the way, they are getting distributed across all these containers, different containers that are there. I have not shown you that, but because of the lack of time, I'll pause over here. What will happen over here is ultimately we will see that we have 3 running containers and all of them are healthy. Maybe if I just go inside this, it will show me all 3 healthy containers. Yeah, it is running and this UI is not updated, but very soon it will show all 3. Yeah, so all 3 containers are healthy. And this way, if you lose any container also, Kubernetes will actually recreate them. It constantly monitors them. So with this, we have launched an entire system using Docker containers and Kubernetes. Hopefully, this would have given you some idea of Docker capabilities and Kubernetes capabilities. What are the things that we can do with Docker and Kubernetes? Okay, if there are any questions, I can quickly take up those questions and we can close this meeting.
Hi, Anurag. We do have a few questions. I'll just share the screen with you. You can just quickly check which of them you have already answered.
Actually, I have those question and answers on my machine. There are 2 windows that I have. One is for webinar chat and other one is for question and answers.
Just a second, I have noted them down. I'm just sharing my screen.
Yeah, in the meantime, I'll just answer one question. Are we deploying the Cassandra in Kubernetes? Yes, we deployed Cassandra in Kubernetes itself. Anurag, what is your LinkedIn? I will just maybe let me just, I do not have the URL. You can search for Anurag Yadav Bangalore. Hopefully you will see my face over there. Maybe that will help you. I will try to send it at the end of this. Let me take any other question.
We have a question. We have a question from Ramesh.
Ramesh,
must be on the screen also. Does the Docker runtime need to match the host OS? Have you answered it?
Yeah, I have. So if you are planning to launch a Windows-based container, then the Docker runtime that you will need will not be a Linux runtime, Docker runtime. It will be specifically a runtime for Windows. Plus, the file that Docker file that you will create, configuration file, that will also be different for Windows. It will not be same as what you create for Linux. So those are some differences. Hopefully that answers the question.
There's next question from Abhinav.
Okay.
Resources
Abhinav,
to learn the basics of scripting of the Docker entry point .sh file. I don't know.
I'm sorry, Ramesh or whoever asked the question. Basics, as you could see that we had a lot of stuff, so we could not cover basics, very basics in this session. Maybe in the training, if you take edForce training, right, of Google, Kubernetes and Docker, there we will be able to cover many more of these things with more detail.
Abhinav, you can drop the details of yourself and you can put us in touch with your LD
I
manager.
think I have run out of battery over here. I will use a different.
Yeah. So the next question is from Pankaj. Oh, your voice is not that audible. I think you need to keep the mobile near you.
Okay, is it audible
Yeah,
now?
yeah, perfect, perfect. So the
Okay,
next
great.
question quickly is from Pankaj. Can you share GIT repo link as well?
I can. So Ashutosh, you'll have to help me with this. So things, let's say my LinkedIn profile, or let's say this repo link that if I have to share, how can we
Yeah,
share it to the
you can just
candidates?
mail it to me. I will send it in the follow-up email.
Okay, perfect. So it will
Great.
take me some time
Sure,
to send you that information. And once you get that, you can share it with all the attendees.
sure.
Okay,
So
thank you.
the follow-up email goes after within 24 hours. So we have a time of about tomorrow. Next
Okay.
is by Nevnatha. Hey, do we get recording of the session and the presentation? Which yeah, you will get the recording of the session for sure. Next is what things are fetching from discovery service to product service? Pankaj is asking.
I'm not sure I got that question. If you can repeat that.
It's on the screen also. What things are we fetching from discovery service to product service?
Ah, so Ashutosh, I cannot see your screen, but I got the question. So discovery service is a concept which is related to microservices. When you launch multiple services, you register them with discovery services so that if any service wants to make to call to any service, it can get the host and port kind of information from registry service. Because in Kubernetes, we get DNS, we can get host and port information through DNS itself, host information. Uh, we do not need registry service in Kubernetes, but hopefully I have explained what registry service is for microservices, and we can have them in Kubernetes. It's completely optional. Uh, if you want to have it, we can have it. Otherwise, it's optional. Hope that answers.
Great. So the next question quickly, you can just skip the questions which you have already taken. Uh,
Yes,
do we need the same OS to entertain the system call from the Dockers?
I think we answered that.
Great. Okay, Parikshit, I hope your question is answered. Next is Sukhveer Singh. How do we differ container and image from each other?
I think I answered that.
Great. Uh, in case if your base system goes down, looks like it will be effect, right? I don't get the question.
Okay, if the question was this, that some container goes down, so we saw this, that Kubernetes can actually bring it up.
Okay, great. Uh, thank you all for being here. Before I officially close the edTalk by thanking Anurag, I just like to tell you, edTalks are a lineup of the finest knowledgeable webinars. edTalks are crafted and delivered by industry veterans to cater to technical cravings of your workforce and to equip them with the emerging technologies and technical developments from around the globe, like one of our edTalk experts, Anurag himself. Thank you, Anurag. Thanks a lot. It was very great of you. And we saw overwhelming response also from our participants. So many questions, still a few left unanswered. I'll send the link of Anurag. You can directly talk to
And
him also. Thanks a lot, Anurag. Thanks, everyone.
yeah, thank you, Ashutosh. Thanks everyone for attending this. Thank you so much. Have a
Please
great
do
day.
fill the feedback form. For those who leave a Google review, we do have amazing Amazon vouchers too. Thank you.
Thank you. Bye-bye.